I am Mohammad Azhar Khan, BE Chemical, 6th semester, roll number 18CH71. Today, the presentation is on the subject Chemical Reaction Engineering, and my topic is rate equation. First of all, I would like to define what is rate equation. Whenever we have a chemical reaction, then in that reaction, one substance is converted into another substance. The substance which react together are called reactant, and the new substance which is formed is called product. Whenever a chemical reaction occurs, there is a decrease in reactant and increase in product. So we define rate equation or the rate of reaction as the decrease in concentration of the reactant per second or the increase in concentration of the product per unit time is called rate of reaction. The rate equation is an equation used to calculate the speed of a chemical reaction. For any general reaction, let's suppose we have two reactants A and B. When these two reactants react together, a new product C is formed. Then, according to the law of mass action, the rate of reaction is directly proportional to the active masses of the reactant. Whenever we remove the sign of proportionality, we put a constant, and where K is constant, called rate constant. Suppose we have a single phase reaction in which the two reactants A and B are reacting together and the new substance are formed that are S and S, R and S. The most useful measure of reaction, the rate of reaction A, is RA is equals to 1 over V, rate of change of A with respect to time, where d and A over dt is the amount of A disappearing per unit volume per second. Its unit is mole per meter cube per second, where the active mass means mole per meter cube. In addition, the rate of reaction of all materials are related by the negative RA over A is equals to the negative rate of reaction of B by B is equals to the rate of reaction of R by R and the rate of reaction of S by S. We put negative sign with RA and RB because the quantity of reactant A and B is decreasing and the quantity of R or S, which are the product, are increasing. From the experiment, we have the rate of reaction is affected by many things. But here we will discuss only the two factors. One is the composition and the other is the energy of the material. By energy, we mean temperature, the kinetic energy of the molecule, because temperature is the average kinetic energy. The light intensity also affects the rate of reaction and the bond energy between the atoms. The magnetic field intensity also affects the rate of reaction. Now we will focus on these factors. Rate of reaction is a function of temperature dependent terms and the concentration dependent terms. Because the rate of reaction of A is a function of temperature dependent terms and concentration dependent terms. This can also be written as KCA, where K is the temperature dependent term, which is also the rate constant, and we know that the rate constant depends upon the temperature, and C is the concentration dependent term, and A is the order of the reaction. This K can also be written as K naught E exponential power minus EA over RT. K naught is the frequency factor, and EA, exponential of EA, is the activation energy. R is the universal gas constant, and T is the temperature because it is a temperature dependent term. CA the concentration, and A is the order of the reaction. If we talk about the concentration dependent term in the rate of reaction, so before we can find the form of the concentration term in the rate expression, we must distinguish between different types of reaction. The distinction is based on the form of number of kinetic equation used to describe the progress of reaction, how the reaction are going on. Since we are concerned with the concentration dependent term in the rate equation, then we hold the temperature of the system constant because we are discussing the effect of concentration. What is rate constant? For any reaction in which the reactant A and B are reacting to produce a product, then from the law of mass action, the rate or velocity of the reaction is directly proportional to the active masses of the reactant, which are A and B. So when we put a constant, we remove the sign of proportionality. So the above equation can be written as dx by dt is equals to K concentration of A multiplied by concentration of B, where K is the rate constant. Now we have a problem in which we have a certain reaction whose rate of reaction is 0.005. That is the concentration. If the concentration is to be expressed in mole per centimeter cube per minute, and the time is in hours, what could be the value of units of the rate constant? Means we want to change the unit in term of rate constant or mole per decimeter cube per mole per hour. Now the rate constant K is 0.05. We know that mole per centimeter cube per minute is equals to K mole square per decimeter cube, decimeter power 6. If we convert this unit, then we know that 1 centimeter cube is equals to 1 upon 1000 of a decimeter cube. Then when we change this centimeter cube into the decimeter cube, the value flips and we have 1000 in the numerator, and we change our, then we divide minute by 60. When we flip the value, it becomes in numerator. Now the value will become 60 multiplied by 1000. That can be written as 6 into 10 raised to power 4. When this value is multiplied by 0.005, then we have 30 into 10 raised to power 1, which can be written as 300 decimeter cube per mole per hour. The problem. which is for a given gas reaction at 400 Kelvin, the rate is reported as the negative rate of change of pressure with respect to time is equals to 3.66 pressure square, partial pressure square, atmosphere per hour. What are the units of the rate constant? What is the value of the rate constant for the reaction if the rate equation is expressed as the rate of reaction of A is equals to the negative 1 over B, rate of change of A with respect to time is equals to K rate constant and the concentration of A. When we discuss about the rate of reaction of the gases, then we take pressure in place of concentration. We know that the negative rate of change of pressure with respect to time is equals to Kp and the partial pressure of A square. This is from the given equation. When we compare the equation with this general equation, then the unit of pressure is atmosphere and the time is hour, which is equals to Kp and the pressure square means atmosphere square. Atmosphere and atmosphere will cancel and the unit of Kp becomes atmosphere inverse, hour inverse. When we discuss its B portion, then from the general gas equation we know that the product of pressure and volume is equal to number of mole, general gas constant and the temperature. When we divide the volume by number of moles, then it becomes mole per decimeter cube, which can be written as the concentration. Then from the equation, the negative rate of change of pressure, partial pressure with respect to time is equals to 3.66 partial pressure of A square. But D, concentration, product of gas constant and temperature by time is equals to 3.66 concentration of A RT square. Then the negative concentration of A with respect to time becomes 3.66 atmosphere inverse hour inverse and the concentration of A square RT. Now new rate constant K, which can be written as 3.66 1 over atmosphere hour. 1 atmosphere per mole, and we know that 22.4 liter by 273 Kelvin multiplied by 400 Kelvin. When we multiply or divide these constant values, we have the value of 120 hour inverse mole per liter inverse. That is the value of K. Thank you.